Let's talk about Lambda functions today. I will share with you 5 advanced Lambda Python techniques that all data scientists should know. So let's check them out. Before I start, what is Lambda function? Let me give you a one-line answer of this question. Lambda functions are one of the Python's most powerful features so that you can write concise and functional style code. The first one, which I'm going to talk about, is how we can chain lambdas with map, filter, and reduce. So one of the most elegant uses of lambda function when you can combine them with functional programming tools. And this approach will allow you to create powerful data transformation pipeline in a single line. Yes, you heard it right, in a single line. So let's see that in action. From functools, I am importing reduce. Okay, so far so good. So what I am doing here, I'm filtering the events, squared them, and summing and doing the summation. Okay, can I see the result now? Let's print the result here now. And as you can see, the result is 220. So in one single line using the lambda function, I have filtered only the event numbers from this one and squared them and also did the summation. So if you see this line, in one single line, I'm doing basically 3 operations. First one is basically I'm finding the event numbers. Second, I am doing a square of that number. And finally, I'm adding that number with the value and finally store that value inside the result. And when I'm printing that value here, I am getting the result as 220. So this pattern is used when you're dealing with a large dataset, and in that dataset, you need to do multiple transformations sequentially. The advantage is that all these operations are lazily evaluated. It means doing this operation, it's not create an intermediate list. And that saves a lot of memory. So this pattern is a very memory efficient pattern. And here comes the real world application where you need to probably clean sensor data by filtering the outliers, normalizing values, and computing aggregated statistics. If these are the things that you need to do on a large dataset, this pattern is really helpful. Let's move to the next one. Next one is all about conditional logic with ternary operators in Lambda. So Lambda functions, they can incorporate conditional logic using Python's ternary operator, making the complex decision in a single line of code. So let's see that in action. So first what I'm going to do, I'm going to import Panda. Then I'm going to create a sample data with age and income. Now I want to categorize based on the age group. If it is less than 30, then it's young. If it is less than 50, then it's middle and definitely greater than 30. And if it is greater than 50, then it's called senior. So let's execute that. Let's do another categorization based on the tax bracket where I am telling this one. And finally, let's print our data frame. As you can see, so age 25, right? Age 25, income this. So it's definitely young because age is less than 30 and tax rate is this. And then again 45, this is a tax rate. So as you can see, using the lambda function, I was able to do a categorization. So this technique is very helpful for data categorization and feature engineering. But one thing that you need to keep in mind, for a very complex condition, a function probably will be your best approach because it will be more maintainable, more readable, rather than writing a heavily nested lambdas. So with that, let's move to the next one. So next one belongs to a very fundamental thing from Pandas. It's called the data frame. And here I'm going to show you how many powerful data frame operations can be performed easily with lambdas. So let's see that. For that, I'm going to import NumPy first. And let's create a sample e-commerce data where these are the products, these are the prices, quantity and discount. So far so good. So now let's calculate the revenue and put that in a new column called revenue. Also, let's create another column called pricing tier where that will be based on the price column. And this is the logic for creating the pricing tier. So let's execute that as well. Finally, apply the complex transformation to multiple columns. So we are creating two more columns, adjusted price and adjusted quantity, where adjusted price will be price column and followed by this logic, and quantity followed by this one. And finally, print the df. So we started with product, price, quantity and discount. So we started with product, price, quantity and discount. We have added one column called revenue, which is here. We have another one called price tier. Revenue is based on this logic. Price tier is basically based on the price, whether it's a budget or mid-range or premium. And finally, we have added two more columns called adjusted price and adjusted quantity, and these are the two more columns. So as you can see, using the Lambda function, it becomes very easy to doing multiple complex operations on the data frame. With that, we'll go to our fourth one. Fourth one is sorting. When you are dealing with a lot of data, sorting is we all need, and how Lambdas function or how Lambdas can help us to do this sorting in a very easy, efficient way. So let's see that in action now. So here is a list of dictionaries of employees, name, and then their department, their salary, and their years. So this is a list. Now let's say I want to sort them by department and then by salary. So let's execute that. Let's do one more sorting, which is based on a custom sorting function. And the sorting function is this: total career earning proxy. So salary multiplied by years, salary multiplied by years, and in a reverse way. This is the sorting function. So let's execute that and let's print them to see how it works. So first level of sorting is done based on the department and then by salary, and then another sorting that happened depending on this custom sorting. And here comes the result. So the sorting happened based on these two sorting criteria. And this is the sorted result where I'm printing the name, department and the salary, name, department and the salary. And the most advanced one, which I kept for the last. So let's see that in action now. And the last one is all about Lambda functions with default arguments and closure. So let's see that in action. So all I'm doing, I'm creating a family of transformation functions. So make multiplier n and then x multiplied by n. So double, I'm putting 2. Here I'm calling this function with the passing the parameter as 2, 3 and 4. And then when I'm calling double followed by 5, it's giving me the result as 10. That's what I'm expecting. And I will anyway execute that. But with the default arguments, that's what it's doing. So let's do that. And as you can see, basically 5 and then multiplied by 2, it's becoming 10. 5 multiplied, and it's a triple, right? Double is this one. So in the double, I'm passing 5. So 5 comes here and it's already 2 is there. So 5 multiplied by 2, 10. In the triple, I'm passing 5, but the 3 is already there, which is default one. So it's getting 5 multiplied by 3, 15. In quadruple, 4 is there. I'm passing 5. For 4 multiplied by 5, it's becoming 20. So using the default argument, it's becoming very easy. So let's create this function. Create scalar, where there is a minimum value and maximum value. And what it's doing is basically x minus minimum value divided by maximum value minus minimum value. Let's create different scalars. Age scalar and income scalar. Age scalar is 18 to 80, 18 and 80. These are the two values. And create scalar, income scalar. Here I'm calling this create scalar with 20,000 and 200,000. Now I am calling them scaled ages based on this age scalar, and I'm passing the ages. Wow, it's so powerful. for all these numbers, x is the number. So 25, when I'm calling this one, it becomes 25 minus minimum value, which is 18 divided by 80 minus 18, and that's the result. So this is really powerful. And this pattern is very useful when you want to configure a data processing pipeline. For example, here, right? It's a create outlier handler with this, and this is a function. Now this is a data frame. And what I'm doing, I'm calling this one with these values and name it as clipper, and finally calling the clipper, passing all enter this data frame, and then I'm printing the data frame. And if you do that, this is the value that I'm getting. So initially data frame was this, and now it came like this. So these are the initial values 1, 2, 3. And what is a clipped value? Clipped value is based on this function, that whatever the logic that is written inside this function. So this is super powerful. So what do you think? What is your favorite Lambda technique? Please drop that in the comment section of this video. And if you like this video, please hit the like icon. Please subscribe to my channel Technical Potpourri, so that when I'll publish the next video, you will not miss that. Till my next video, stay safe. Thank you. Bye-bye.